3.1, quadratic functions and models. What we're going to learn is to analyze graphs of quadratic functions. We're going to write quadratics in standard form and use the results to sketch some graphs. And we're going to find minimum, maximum values. Okay. So the definition of a polynomial, as stated before, we've stated this a few times, but we'll let n be a non-negative integer and let a sub n minus 1, all the way to a sub 0 be real numbers with a sub n not being able to be equal to 0. Okay, so that means that the lead coefficient is not 0, which is important because we're defining the polynomial based on that. So then that means that f of x is equal to a sub n x to the nth power, which is the lead degree and the lead coefficient to the polynomial, is a polynomial in x with degree n. And that's what we're saying. That's what we're defining the polynomial really totally as, but we give it the name based on its degree. Okay, and that's why it's in standard form. The definition of a quadratic. So the big thing is that it's a degree 2 polynomial. Okay, that's the big idea. So if we let a, b, and c be real numbers with a not being equal to 0, then we have a function in x that is ax squared plus bx plus c equals, well, we'll find later that it is a quadratic function. The vertex form for the quadratic here is f of x, and I've given this in an earlier tutorial, but hopefully, I'm hoping that maybe this one or an upcoming one will show you how to go back and forth between the two different forms. But the vertex form is very powerful because it does give the vertex at hk, which is either going to be the minimum value or the maximum value for the quadratic. Okay. And again, in either one of these cases, if a is greater than 0, it opens up. And if a is less than 0, it opens down. So up and down. Okay. So here is a way to actually look at minimum and maximum values for quadratics. Now, what this input value of negative b over 2a is the line of symmetry. Is given at a particular x value, and that is at negative b over 2a. Okay, so that's where we got that. All right, so with all of that information, we can now start to do some examples. So here we have an example, h of x is equal to x squared minus 8x plus 16. Now, I'm going to look at this as the fundamental way of the concept here of finding the line of symmetry, or the axis of symmetry. We're going to evaluate the function at the input for that line of symmetry, and then we're going to make an easy step away from the axis of symmetry and evaluate that function so that we can get the 3 points needed to graph the parabola in this case. So the very first thing that we're going to have to do is find the line of symmetry. So I'm just going to call that x sub LOS, and that's equal to negative b over 2a. And I'm just going to label it like this so you can see where I'm getting all these letters, numbers for the variables for. So a is equal to, b is equal to, and c is equal to, even though we don't need c, it doesn't really matter, but a is 1, and that came from 1x squared, and b is a negative 8, that came from the linear term here, which is negative 8, which we discussed in lecture, and c is 16, which we don't need, so I'll just put that in black, and that's the constant. So what we need to do is just put our values where they belong. And notice that I didn't lose that negative. So this all looks like it's going to crunch down to 8 divided by 2 or 4. So we have an axis of symmetry or a line of symmetry at x equals 4. That's important. Now what we're going to do is, just like we said, we're going to evaluate at that particular value. So we're going to take h and we're going to evaluate it at 4. So the original equation was x squared minus 8 times something plus 16, and now we're going to input the value 4. Now this will tell us, what this is telling us here is that the height or the output at x equals 4, right? So that'll give us this particular point or the vertex point. So that means that what we have is 16 minus 32 plus 16. Oh wow, that's kind of nice, because we just found out that h of 4 is equal to 0. Now that's another important value, so I'm going to keep it in a box. I'm going to box it so I can easily refer back to it momentarily. Okay. So this is really saying a few very important parts. We now know the vertex. So if we combine these, we now know the vertex point, which I'll just call V. And at a value of 4, we have a height of 0. So those two pieces together gave us some very valuable information. Now all we have to do is pick a point that's going to be very easy to find. Now, at this stage, what I'm going to do is I'm going to try to draw a very large graph here, or a larger graph than I normally do. Okay, maybe I'll make it down here, like that. And now we know that there is a vertex point. There is a vertex point at 4. So if I go out, let's just use these tick marks, 1, 2, 3, 4. Okay, so I'm at 4. And I'll label that as the vertex 4, 0. Now what I'm also going to do is, maybe in a really weird blue, okay, I'm going to draw in the line of symmetry at this point. So I'm just drawing a vertical line indicating here is the line of symmetry. Now, since we know that the A value here was positive, we do know that it opens up. So because A is bigger than 0, A was 1. So it's definitely bigger than 0. This will open up. And that's nice to know. But what's better to know is an actual height. And what I'm trying to state here is that I'm going to take one step forward or one step backward, okay? Now, if I do that, it will allow us to make some really nice calculations. Now, we could do that. We could take one step backward or one step forward, and at either one of these points, the outputs would be the same. So what I meant earlier by taking an easy value to go back to is I'm actually going to go all the way back 4 units. So I'm going to go back 4 units because then I can evaluate h at 0. And that is an easy evaluation to do. And what we'll do is we actually can do it right here. It's just going to be 0 squared minus 8 times 0 plus, I think it was 16, if I'm not mistaken. Yep. So that means that at that input 0, we're up 16 units. I'm not sure I'm going to be able to draw this according to scale. In fact, I'm pretty sure I'm not going to be able to. Maybe a little. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, we just got lucky. Okay. So at this point, we know that we're up 16 units. Now, because we made that nice 4-step backward, if I take and I do 1, 2, 3, 4 steps forward, then we're going to have the same exact output height that we have 4 steps backward. And then this is going to be, well, the x value is now going to be 4 units more than what the vertex was, so because we went plus 4 units. So it looks like we're at 8 now and a height of 16. And at this point, we now feel comfortable enough to be able to draw our wonderful parabola. And, I'm not perfect, so I can't draw it as good as a computer can. But hopefully you can see that what we have here is h of x. So now let's look at finding the vertex form for a quadratic. And there's two main cases, or two main ways that we can look at it. One is by factoring, and the other is by completing the square. And I'm going to show you a portion of that in this tutorial, but I'm not going to go through the whole mechanism. That'll be for another tutorial. But if I look at number 1 here, and I look at f being 2x squared minus 16x plus 32, it's easy to see that I could factor out a 2 from every one. So I'll just circle that. And then, again, what we're looking for are the factors of 16 that combine to give you 8. In this case, negative 8, which means that both of them have to have a negative or a subtraction here, in which case I just rewrote it in a nicer form. Now, if we wanted to identify the I thought I changed colors, but if we wanted to identify the vertex, remember it's just hk, and in this case k is 0, and h in this case it's already negative, so it's at 4, and it would be 4, 0 would be the vertex. Now, in this case, it's really nice because the vertex is in fact the height of the vertex is directly on the x-axis because the y equals 0. But let's just say that we didn't know it, and we wanted to find f of x equals 0. Well, then all we'd have to do is set it equal to 0, and then solve the process through. So very easy to do. I don't know if you really need me to do it. I guess so. So 0 is equal to x minus 4 all squared, then square root, right, of 0, and then that's just going to be, well, 0 is equal to x minus 4, and in this case it's just going to be 4, which we already knew, right? I mean, that's why I didn't know if I had to do it or not, but just to kind of show you, in this case there's really only one intercept. So if we did want to graph this out, we'd be at 1, 2, 3, 4 units, and we'd be going up pretty steeply because of the stretch, right? The vertical stretch that we discussed before. So in this case, 4, 0. Alright, another example. Here we'll look at f of x equals 1/4 x squared minus 2x minus 12. And one of the simple things to realize is that we have that denominator form. So what we're going to do is we're going to change all of those to having a denominator for each one of the coefficients. So this will be 1/4 x squared minus, it looks like 8/4, right? Because 8 divided by 4 would be 2x. And then that looks like it'd be like 48 or so, I think, right? Because when we divide that by 4, we would get 12. So the only thing we're doing here is making common denoms. And that way we're hoping that if we factor out that 1/4, now we might be able to factor this polynomial a little bit easier, is our hope. So from here to here I just factored out 1/4. Okay. So all we have to do now are find the factors of 48 that might combine to 8. And if we can't, then it won't be factorable. But if it is, then it is factorable, and we can do some stuff with it. So what we do know is that the factors of 48 that do combine to 8 are going to be 12 and 4, right? Those are going to be the easy numbers. So if we look at 48 and I look at the factors of 48 and I say that it's 4 and 12, then we can actually make a combination of 8 if we have a negative 12 and positive 4, right? Because we want to make that negative 8 right there. So it looks like it is factorable, and it does factor nicely here. So we have 1 and 2 factors, both with x. One of them has to be a minus 12, and one of them has to be a plus 4. And if you do double check, you can see that it does in fact work out nicely. So f of x is now this beastie right here. Now, it's not technically in vertex form, but what it is in a form that we can decipher the vertex quite easily. And that's the easiest way to look at it is by first going back and finding the x-intercepts. And that's easily seen if we do this out. I mean, it should be kind of obvious that where the zeros are going to be is going to be at 12 and negative 4, but just in case, well, you're solving by the zero product property, so you have x minus 12 is 0, you have x plus 4 is 0, and the 1/4 just goes away because of 0, so it's x is equal to 12 and x is equal to negative 4. So now if we actually draw this out, let's see, do I have enough room here? Let me pause. Alright, so I think I've made enough room here for the graph to try to draw this out a little bit to scale. But first what we have to do is look at the intercepts, as like what we said. So I'm going to put one back at, 1, 2, 3, 4. So we have 1 point right here at negative 4, 0. And then we have another point at 12. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So it looks like we have another point here at 12, 0. Now, why is this important? Well, because it gives us the line of symmetry directly. The only thing that we'd have to do is substitute to find the actual height of it. But if you think about it, the line of symmetry has to be equal on both sides. So we have to be an equal distance from both the 12 and the negative 4. So what are we actually finding? Well, we're finding an average. So if we just take this, we can find the line of symmetry in this case by just taking the negative 4, adding the 12, and dividing by 2, which in this case just gives us 4. So if we go in, now I'm doing a different color here, blue. So if I go 1, 2, 3, 4, it looks like right here we would have the line of symmetry. So here we have x equals 4, and that's the axis or the line of symmetry. Then what we should see to go forward and backward from this point is that there should be 8 units going to here and 8 units going to here. So if we see what I'm trying to get at here is that if we go out a certain number of units from this point, whoops, no, that's not good. A certain distance from this point here, well, if we're at 4 and we need to get to 12, then that's positive 8 units. If we're at 4 and we have to go backward for more units, then we're also going back 8 units. So we do have that symmetrical focus on this point here now. So the only thing that we have to do is evaluate this at x equals 4, and that becomes very easy. So let's just do that in blue. No, not blue, because I use blue for that. So hot pink. So I'm just going to do this in f of 4, and what was the original one here? It was equal to 1/4, and you don't really need to use the original. I'm just doing it to remind you guys about how to practice. But if you use the factored form, it's a lot easier and a little faster. So I'll let you do that one. But if you see it, you can kind of get away with doing this one a little quicker, right? I'm dividing by 4, but I have 2 4s that I'm being multiplied by. So this looks like it's going to be 4 minus 8 minus 12. And that looks like it's going to be, well, that's nice, right? That's 4 and a negative 20, which looks like a negative 16. So at f of 4, we're at downward 16 units. So let's see if I can even draw this into scale. I'm not really sure, but we'll see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so we're down here. Way down here is the vertex 4, negative 16. And at this point, we are very confident in being able to draw our parabola. I was looking so good up until that last point, so let me try that one more time here. We're not computers. So hopefully that makes a lot of sense. Let me just draw this all the way through, and there.